Okay, I'm going to start this session. This series of talks is called Keeping People First in AI. So this is an academic session that prioritizes human-centric values in development and deployment of artificial intelligence, ensuring ethical considerations and societal needs remain at the core of AI innovation. Our first speaker this morning is Dr. Ga Wu from Acadia University. And his talk is Beyond Search, Interactive Information Retrieval in the Age of Agentic AI. Go ahead.
Thank you, Andrew, for the introduction. Okay, I'm really kind of a pleasure to be here. I was preparing my slides for 50 minutes, and eventually I found it's only 12 minutes allows me to talk about the story. So I significantly shrink it down. So if you have any questions, please let me know. So my topic is Beyond Search, and this is a real kind of situation that happened in the industry that when I talked to a company so-called Trustworthy AI, so they want to build an AI platform so that to match the investors and the startup founders and the employees. And they're really kind of ambitious goals. And they do have this strong technical stack that they have those OpenAI APIs, it's paid version, right? They also have those optimized the prompts, right, with some prompt optimization policies. They also have those well-developed skills that if you know the agentic system right now, the most hot topic is skills, right? So that they invest a lot of time to design those skills. And they're trying to get the best match between those people who are using their platforms. But they do have those type of questions at the end that after half year of development of those systems, and they asked me that what's happening here, right? Why this system is not behaving as the state-of-art system because they're already using such a lot of technologies, those buzzwords that have been all included in their pipelines, but they still don't perform well. Okay. The first question is that they sometimes see those corner cases. The large language models does pretty well. The agent system does pretty well in general cases. But once that it gets into those corner cases, for example, there are two founders have exactly the same ideas, and they want to pitch the same ideas, but they are matched with each other. And they're pissed off because that they don't want a competitor, so they want someone who can invest their idea. And that has become the big problem. And the second problem is that there's some problems that in the system, but you cannot make any interpretations or debugging on top of these large language models. And that's causing the system hard to manage. The third one is a little bit minor. That is about the rankings. And you know the large language model is not good at scoring. Okay. So let's talk about this, what's happening. So the first thing that we see is that there's some corner cases. If you look at those really well organized profiles from their system, is that they are able to use these large language model systems to produce these user profiles with several sections, like look for sections, background sections, or constraint sections. And each of them are detailed describing what the user is looking for and what his background is. But if you look at how they match the system, you find the first person is looking for senior background engineering positions. But the second person has a background of those senior engineering positions. It's supposed to be semantically a good match, right? But that is not really human need, right? Human doesn't want it. What we want is that when I search for senior background engineer, is that I want that position, not another person with that background, okay? So that is the problem, and that is what people observe. And the body, this company asked me that, what did we do wrong here, right? So to answer this question, that we'll start with this, what's the property of the agentic system. Why does the agentic system, matching system, misunderstand people's intention? So let's review that how classic recommender system or information retrieval system to handle these cases. So the traditional system is actually a pipeline that starts with very simple candidate generation, several layers of rankers, and then the safety filters that remove the bad matchings. And here, this candidate generation is a really simple machine learning model or maybe heuristic models to get rid of those bad matchings at the beginning. Right? And then the later filtering or ranking system is simply reordering the items or reordering the matchings so the users can see the best match as first. Right? So if you look at any of those things, so for example, let's look at those candidate generations. the candidate generation is simply coming from a user item matrix predictions, right? So think about any entry of this user item matrix is simply the historically how this user gave the feedback to the certain item. Our goal is simply just filling up those question marks with the corresponding numbers. So we know that how the user will like the item eventually. And the candidate generation is doing something very simple, is that I'm assuming that user have some user embeddings, item have some item embeddings, and I do the dot product. So I know that the user will like this item by simply computing this dot product values. Super easy, right? But where are those embeddings coming from? This embedding coming from a loss functions that you're trying to train this user embedding and item embeddings to match the ratings, okay? Easy to understand. And then that you can look at the user embedding is coming from a one-hot encoding of the user ID and the trainable parameters. And that is everything about it. So that algorithm so-called matrix factorization, or that in the most kind of well-known name, that the abstract level name is so-called collaborative filtering. And you will find that this entire thing doesn't use the user-provided information, right? It's not using the user descriptions or item descriptions. Totally get rid of those. And we're only using those rating matrix to make the prediction. But the system still performed well for years, right? So why it performed well? The thing is that it started extracting something implicitly that from the rating matrix. The user may be not really good at expressing what they need, but their behavior will tell you what they need. So that is not just about candidate generation. You can also think about heavy ranker, light rankers. Now that you have those user profile information or item description information, it seems like you have more things that you want to take care of. But your model is still kind of a two-tower model. So you still have this user embedding and item embeddings. But the different thing between this one with the large language model is that those embedding system is carrying, again, the implicit interest of the users. Even the user never expressed it. Okay, so that is something very different between this traditional recommender system with the large language model. So clearly, the large language model is missing something, and here is something that we can see. Okay, so the next question, right? The second problem that we mentioned: why does the agentic matching system hard to debug and intervene? To answer this thing, that we can still go back to this traditional recommender system. Here is a really classic two-tower model. You have this user embedding, you have the item embeddings, and then you go through some neural networks and you predict if the user will like the item. Again, super easy, right? But also at the same time that you always having a chance to explain why the user likes this item as additional prediction branch, right? You can project that into your trained models and let it to explain what the model is doing. And then that you can even allow the users to disagree with some explanations and put that back to the models so that change the model behavior. So that means the traditional model allowing you to do some intervention on top of it and allowing you to quickly correct some errors in it. And now that this is not really a kind of special case, you can use another conventional recommender system like the autoencoders. Also similar thing that you have the user encodings and you have the explanation sections and you can intervene this explanation such that to change the model's behavior. Okay? So now let's look at how the large language model or the agentic system is doing. You now only have one single block of large language model. It's that I'm going to encode all the things that you're given to me. I'm going to do the reasoning on top of it. So where your information coming from? Simple prop. But this is great, right? This is easy to work with. But the problem is it is totally a black box. You don't know how the model is trained. You don't know how to intervene it, right? And even some people are super smart, right? The people think, okay, I can let my large language model explain it. I can let it to explain why it's making decision. But historical research already showing the large language model will generate some explanations that is totally different from how it made the decision. Okay, so that means the explanation is totally not trustworthy. And now we're making the large language models hard to maintain. So now that we understand why the agentic system cannot be intervened or cannot be explained properly, and also why the agentic system doesn't perform well as people are expected. Okay, So what is our solution? Right? What is our solution? I changed my solution that in two pieces. One is engineering solution, right? How the company is supposed to be address this problem right away, and what is a long-term solution that how the research is supposed to be following up to make the once for all solution. Okay, so our solution is that the agentic system should not be a standalone system, right? We're assuming the agentic system is such smart that you give the raw input and make it to make some prediction. And this is many companies are currently doing. But my suggestion is that instead of treating it as a standalone solution, you should put the large language model or AI system as part of your information retrieval pipeline or recommendation pipeline. You still want the first several stage of the pipelines that to capture those so-called implicit feedbacks or implicit interest, so that you can fill up the errors that we see previously, right? And also, the better name of this agentic system right now is supposed to be a matching assessment system rather than a ranking system. Because the large language model is really not good at scoring or ranking. It is only helping you to filter out bad matchings. So that is supposed to be in a different name. So that is the first thing we changed. The second suggestion I gave to the company is that we don't want to use one single prompt that to say, this person will match another person. That is too brutal, and that you're relying on the large language models to give the strong reasoning abilities to reason the corresponding scores. But I think that many of you already tried that you're giving some question and let large language models to give the corresponding scores. But you know the scores are really random, right? Really random. It's not totally not reliable. So in this case, that we borrow the idea from the courses, the university courses, that we always define some rubrics that to grade student assignment, right? So in this case, that you can separate the large language model's task into the several different small subtasks, and each of them giving us corresponding weights and the corresponding duty of measuring the submission. Okay, so with this improvement, that you're able to explain where it's coming from, where the decision coming from, why this model believes this user should match another user. Because right now that you can see, it is either from the location match, or this is either coming from the role intention alignment, right? So now that your explanation is aligning with your decision making. This is not a pure post explanation. It is the explanation coming along with your decision. So if anything goes wrong, that you can go back to see that which part of your rubric is giving you a red flag, and you say, okay, that I need to make more investment or investigations on that part. Right? It's better use of engineers' time to look for the bug. And also at the same time that we introduce those pair rubric section matchings. So that means we want to reduce the large language model's vision on looking at the context. So we're always assuming large language models able to pick up the right context from what you are given to it. But that is a wrong assumption, because we realize the large language model is really sensitive to what you're given to it and like using it in the right way. So as a human, that we should give the large language model a prior knowledge, and this prior knowledge limits that what it's supposed to be looked at, and then how it should make a decision based on. Okay. So that is the second thing. Of course, that because it's a matching system, that we're doing the two-side matchings from user A to user B, and also from user B to user A, so that you got the two pairs of scores. So now that we solved the second problem, is that we are able to explain what the large language model is doing, and also that we have the space to intervene the large language models to address this problem. So like with all of those changes, that we're able to improve the company's matching success rate from 17 to 28. And that is a huge improvement, just simply changing how the large language model is used in that entire business pipeline. Right? There's no much fancy things, but now that the simple small changes allowing you to get a big performance improvement. So that is the engineering solutions. What about the research, right? What do we see from this research? if you look at this, the previous method that I shown that in the previous slides, that the traditional recommender system allowing you to add into explanation sections, and then that you're able to criticize the explanations such that to change the model behavior, right? But large language model doesn't have that flexibilities or ability to extend. So my PhD students come up with a good solution that is through the control via request-aware masking. So the basic idea is simply that if the user have some request to say, oh, I think that your recommendation is bad, or your recommendation is somewhat not satisfying, then I can inject those requests into the large language model as masking system, right? We simply mask some parameters of the large language models, and then the large language model will change its behavior because some forward path is being blocked. Okay, so how to train this? There's a little bit math behind of it. I'm going to try to ignore it. But you will see that the effect is that if you have this type of recommender system that the person eat burger, salad, and curry, and then that you want to estimate what the person will like consume next. And the current prediction, current explanation or recommendation is a beef steak. So if the person said, I was hoping for something lighter and fresher, and this information is supposed to be injected into the large language model such that the large language model makes its prediction in a different way that is satisfying the user's immediate request. Okay. How it's been achieved? A big math. But I'm not going to describe it. If you're interested in this, please read our paper. So this paper is just accepted on the ICML 2026. Okay, so thank you.
Maybe I don't. Oh, I do need still the mic. Thank you, Dr. Wu. Any quick questions for Dr. Wu before we move on to our second speaker?
Yep.
When you're modeling a user in the early units, you were modeling a user as a single instance, but oftentimes people are actually sets and sets, and so sometimes when somebody wants something one more time, changing what the user profile actually is. So are you looking to multiple profiles for users at all?
No, so like the conventional idea that in this simulation is that we are assuming the user embedding is normal system. So what is normal system? It's saying that if the user interacts with some items, then that his user profile information should be influenced by that particular item. So the items embedding will be copy-pasted to this user embedding so that you can imagine the user embedding is hovering around this item space, and this is so-called normal.
You speaking with Mike?
Okay.
Yeah, sure.
Okay. Yeah. Okay. Does this answer your question?
Yeah, it does. So somebody at work for somebody at home ends up having different preferences, so they can pick one of it and analyze the user
Yep.
and end up having different experiences.
Right. Yes. So we also like want this intervention system that I described that in this talk, that to allowing that people to immediately like express their preference so that the system directly change to something that they immediately needed. Okay. Cool.
Okay, is there maybe one more quick question for Dr. Ga?
No.
Okay. Thank you so much. A very quick question. When you are talking about the job seeker and job posting, HR and job seeker matching, is a very interesting scenario. I'm wondering, have you ever tried to use a model to rewrite to paraphrase the user profile, like paraphrase the job seeker profile? Because when I was developing the RAG solution, if you paraphrase a sentence, it will retrieve a different set of results.
Yeah.
Have you ever? Yeah, just the question.
Yeah, that's a great question. So that is actually where that companies start with, right? The companies that try the different pre-processing approach, query expansions, and also atomic fact description of the user profiles. All of those things were in their map. But eventually, the problem is not about why the large language model couldn't understand people's intention from the natural language processing perspective. It is because that some critical signals are missing that in their pipelines. So the critical signal missing is that users' behavior is very different from what they expressed explicitly. So for example, even I say that I like the computer games, right? So that is my expression, but my expression is a little bit restricted with this granularity I describe these things. But if you think about the real human that they express their interest, it's potentially just click some games to buy, and that is much more specific and much more, like sometimes it's even contradicted to what you describe. And the human doesn't understand themselves sometimes. Does this answer your question?
Okay. Thank you, Dr. Wu.
Thank you.
We'll thank the speaker one more time and bring on our next speaker. I guess you can try to. Okay, our next speaker is going to be Dr. Andrew Bazell from VidCruiter and from Western University. We're going to see if we can get the slides fired up here quickly.
So my name's Andrew Bazell. I wear two hats here. So I'm the Chief AI Officer at VidCruiter. We're an HR technology company. We've been around for over 15 years. AI is everywhere in HR technology. It has been for a long time, frequently quite badly. So what I do at VidCruiter is I lead the development and engineering and planning of AI in our product, but I've also increasingly been focused on AI adoption. Secondly, I wear another hat. I am a postdoctoral associate at the Rotman Institute of Philosophy. I spend a lot of time thinking about ethical and social impacts of AI, the way they sort of change the way that we think and work together. So sometimes these two hats are nice to have. Sometimes they kind of come into conflict. What I want to do today is like a little bit of an industry talk, but a little bit of a philosophy talk. And I'm going to talk about a feature that we've been building at VidCruiter and the considerations that we have been bearing in mind as we've built it. And the thing that I've noticed that those are the same considerations that I think matter when we think about AI adoption as a company. So that's the sort of arc. So the thing I want to start with is I spend a lot of time looking under the hood of software platforms that perform some specific business or task where AI is being added to them. And I also see, because I spend a lot of time with IO psychologists, so I read their papers, I go to their conferences, I see these studies that try and compare. Here's how a human would rate an interview. Here's how humans would build test items. And here's how AI does it. When I look under the hood of both of these things, and bearing in mind, we're not talking about like highly specialized, dedicated AI research. This is applied AI. I look under the hood and I frequently see this very naive, simple one-shot prompting. And we all know this kind of works, right? We can do it off the side of our desks, and we can get pretty good answers. But when we're trying to enable judgment and domain competencies at some scale, treating AI as a super genius is not really a great metaphor. It has all kinds of problems, some of which are going to be very familiar to you. It's very sensitive to input conditions, so like little changes in what you give it can cause big changes in what you get out the other side. It's opaque, and not just in the way that we think about of deep learning systems being opaque, but it's just plain old epistemically opaque, like a person that gives you an answer and won't explain themselves. Such as we can get reasons out of them, they tend to come post hoc. They tend to be like rationalizations or parallel constructions. And frequently when you see people trying to change the behavior of these things, you get these prompt pylons, right? So, and do this, and don't do that, and try and be fair, and try and be accurate, and make no mistakes, sometimes with demonstrations. And finally, it's just that reason giving, which is frequently what we're looking for, and I'll come back to that, is more of a practice of being answerable to others than just producing justifications. So the AI feature that we've been building at VidCruiter is the one that we've resisted building for a long time, which is AI assessment of interview content. And for a long time, our stance was always educational. It doesn't work. It's not fair. It's very hard to make it do what you think it can do for you. But increasingly, market pressures have forced us to go there, but also increasingly the technologies and techniques available to us have allowed us to approach the problem in a way that we feel comfortable with. And so this is the assembly line metaphor. And so what we've done is we've taken a long time to engage with subject matter experts, IO psychologists, CHROs, people that are using these things, and we've decomposed everything involved in that one square, which is the thing we need to sell, which is assessment. And we've tried to think about all the other cognitive tasks. And within these boxes, practically, these boxes are even smaller, and there's more decomposition. And some of these are flows, and some of these iterate. But what we've tried to do is think about what is the cognitive labor process that we're decomposing, and what are the cognitive units of that labor that we need to perform. And we think this architecture, initially, it meets a lot of technical constraints that we cared about, right? We wanted to be able to assure ourselves and our users that the same constructs, the same answers are rated the same way no matter how they're presented. We want to be able to have test, retest determinacy. We want to be able to make precise changes to how these things are behaving. We want to be able to conduct evaluations that actually can give us meaningful information. We need to know what we're evaluating and what part of the task processes are going wrong. And we just want it to be predictable in real world conditions. But you'll notice these technical constraints start to blur into what we would think of as normative constraints, right? What do we really care about? We care that we can give comprehensive explanations of what's going on. We care that these intermediary artifacts that are generated aren't just rationalizations, but they're causal, that they have something to do with what's going on. We can hand check them. We can substitute a human for any one of those tasks, and the overall process will basically do the same thing. And so this starts to track, again, more normative interests in things like procedural fairness, and the commercial interest that the selection decisions that our tools make are actually good ones, where you're hiring the right people. You're not missing out on excellent candidates because your systems are blind to them. And underlying that, we spend a lot of time helping our clients understand their exposure to best practices, codes of conduct, regulations, and laws. And these reflect these very basic human interests in things like equality of opportunity, fairness of assessment, fair allocation of limited resources. So the technical constraints sort of lead us to these normative constraints. I specifically want to call out explainability. So we often think that explainability is this sort of box ticking thing that we have to do. And you see it in compliance exercises, and you see it in frameworks, we see it in regulation we have to comply with. But explanation, it can be good and bad, right? There's adequacy of explanation. And the thing that we're interested in is the extent to which a real reason is vulnerable to challenge. And when you challenge it, it can actually change the decision. And we're trying to ask ourselves, what's the sort of functional analog of that in an AI system that we're trying to build in HR products? So the driving metaphor of the assembly line is an evidence-producing machine, not a decision-making mind. And the assembly line metaphor is sort of Taylorist, right? There's a very ruthless decomposition into the smallest sort of cognitive task units that make sense to us. But it's pretty much the opposite of Taylorist in its motivation, right? So famously, Taylor was trying to remove human variation and human judgment and human discretion in order to standardize what comes out the other end of the process, whereas we're trying to decompose it in a way that fosters and affords human judgment. That's the design goal for us and a technical goal. But the tricky thing is that judgment increasingly seems like a nice to have, and it's often treated as a nice to have, even though you would think it ought to be a need to have. We actually should need to make sure that we're building judgment into these systems. But increasingly, it seems optional. And I've been thinking a little bit about why that is. So I'm going to throw this idea on the table. Initially, I was thinking about it in a way that, so my background is philosophy. Philosophers would make this distinction between things that are instrumentally good and things that are intrinsically good. And things that are instrumentally good just because they help you get to the things that are intrinsically good, or at least that you think are intrinsically good. So the distinction between formal rationality that Weber makes is more about how we make decisions or pursue goals as institutions, or as knowledge systems, or in groups. And we can have formal rationality, where we have processes that produce judgments, that make sort of complex social decisions that are calculable, consistent, and rule-governed. But there's also substantive rationality. Does the outcome actually serve the values we hold? Is it doing a thing we care about? Is it doing it in a way that we care about? And this is the difference between, in a bureaucratic environment, knowing that mechanically someone belongs in pigeonhole A, but realizing for a bunch of messy, nuanced, kind of gray area reasons, they really belong in box B. One of the things that AI lets us do is kind of mass produce systems that give us various sort of flavors and applications of formal rationality. And increasingly, almost any cognitive task can be made calculable and automated. And to me, this has been an astonishing development. So like things I could not imagine doing in a relatively simple and automatic way, even a year and a half ago, we can do now. But formal rationality doesn't certify itself. So a process can be flawless, but aimed at the wrong thing. I'm sure people in the room are very familiar with all these examples of reward hacking, AI systems or goal-directed systems that optimize for the wrong thing. So finding annotations in X-rays instead of the thing you're looking for in the X-rays, or getting points in this game that OpenAI tried to get a AI system to control by crashing the boat and not crossing the finish line. This whole sort of basket of bad optimizations has a very nice term that came out in a paper just a couple of years ago that calls them proxy failures. And they're called proxy failures. This is exactly when the formal rational process starts to drift from the substantive rational process, where the thing that we've put in place of the thing we really care about stops tracking it. So for example, we might care if we're trying to set up agentic coding systems. We want to know, are our features well built? Are we following good engineering practices? Are we breaking other stuff? And so our proxy is frequently, do the tests pass? But if the AI is also rating the tests and it's rating it based on the code that it's writing, you're missing some ground truth, and these two things are going to drift out of phase. The same thing happens with benchmarks. We use a lot of synthetic benchmarks in our work. Obviously, the big model producers use an extraordinary amount of benchmarks in the work that they're doing, but you have these proxies break when you get things like test contamination, where the benchmarks leak into the training data. In our use of benchmarks, they can break when the systems that are building them have the same blind spots as the systems that we're testing with them. But the innovative use of proxies increases vastly the things that we can automate, but it makes judgment and monitoring more important. But it's also harder to do, and it's harder to do because of the scale. Because every time we automate one thing, we have a byproduct that needs oversight, and at some point we tend to exceed the human capacity of our ability to provide meaningful oversight of that. And I think often people that I talk to that are thinking about AI adoption in their organizations, they feel this sort of dissonant conflict between two mandates that they tend to be given. Especially chief AI officers will talk about this, that we need to increase AI adoption. There's a keeping up element, but there need to be humans in the loop. But humans in the loop very quickly becomes a bit of a platitude, because the speed and scope of AI adoption makes it very difficult to put humans in the loop in a way that actually matters. So I want to talk about speed and scope for a second. So there's been increasingly this idea that we're headed towards this world where, intelligence will be a utility. The price of intelligence will go to zero. I highly doubt that's true. But certainly there's this idea that more and more and more and more cognition and intelligence is something that's just out there and available for anything that we want to use it for. And it reminds me of a question that Herbert Simon asked way back in the 70s about surpluses and abundances of information. And the question that he asked, which I think is really useful, is when you have an abundance of something, you tend to get a scarcity of something else. If we have a surplus of information, what does a surplus of information consume? The answer that Simon gave us was attention. So a surplus of information creates a poverty of attention, or a scarcity of attention. And indeed, this is a nice question that opens up a lot of interesting analysis that we can do, and I think the answer probably rings pretty true for us. So the question that I've been thinking about for a while is a similar question. I used to like to ask it, what does a surplus of intelligence consume? But I think intelligence is a bit of a loaded concept. So I've started to prefer to call it cognition, because it seems like it's cognitive horsepower that's available to us more and more. And then the question that I ask is, well, what does that consume? Surplus of information consumes attention, makes sense. What does a surplus of cognition consume? So the answer that I've started to think about more and more is culture. And there's a dozen different ways of cashing that out, but I'm going to focus on just one right now, which is the concept from anthropology of communities of practice. So this is a way of answering the question, people that are experts in very complicated, very nuanced things that require a lot of tacit knowledge, a lot of domain knowledge, a lot of expertise. Where does this come from? And it comes from groups of people who share a concern or passion, who get together, they work together, and they learn, and they interact regularly. And communities of practice is how this expertise is created. So if I think that a surplus of cognition consumes culture in this particular way, I need to have a mechanism. And the mechanism, I think, is the fact that for almost anything that we do, at least feasibly, we can cognitively offload it. At least feasibly. There's all kinds of arguments that it won't work very well, the answers might not be very good, they might not be reliable, but we can at least kind of do it. And that's new, I think. I don't think that was true even a couple of years ago. But when everything can be possibly offloaded, we start to multiply the demands on us from the offloading and from the monitoring, and from making sure that we're not falling into various sorts of proxy failures. The other observation, though, is these tools are very much dyadic, right? It's us and the tool. And so there's a lot of Slack messages that I used to get that I don't get anymore. And there's a lot of Slack messages that I used to send that I don't get anymore. And the juniors in our company and the interns, which we are still bringing in, thankfully, spend a lot less time asking the seniors things because they now ask their AI tools. So the AI tools sort of, they tend to keep us in silos right now when we bring them into our organizations. And so the idea of this consumption of culture is the worry that, in order to maintain substantive rationality, we need this social substrate of communities of practice. And AI, as we're adopting it, seems to be eroding that, right? And if I come all the way back to the future that I was talking about, what were we worried about? The worry was we're not going to be able to treat this as a thing that can help us give reasons. We're not going to be able to prove to ourselves that it's maintaining some kind of substantive rationality with regard to the thing that we're trying to do. And so the problem for us is, how do we structure it? How do we take what we can do in terms of automation and AI and structure the process in a way that actually is deliberately and intentionally focused on letting us understand it and reason about it and produce reasons from it and keep it aligned with the things that we care about. At the institutional level, and maybe this comes from working at a software as a service company, but there is an incredible amount of hand-wringing and existential angst about what generally available AI is going to do to the things that we make. Because if AI can possibly generate almost any artifact that we generate, we start to ask ourselves, then, what is our value proposition? And I think the answer to that is sort of like the process problem from the feature I described. We have to ask ourselves, what is the substantive layer of what we're doing, right? We're not just plumbing. We're not just making bits move around. There's a purpose to this. And how do we make sure that we're staying in touch with that purpose? So at VidCuter, concretely, what it's done for us is it's led to us reorienting and embracing engagement with subject matter experts much more than we ever have done in the past. We're making big investments in human studies, trying to understand how our tools work, how other tools work, how people think about the tasks that we help them perform, building evaluation tooling, partnering with academia, and you'll probably recognize this is us trying to build that community of practice, trying to build that sort of substantive, here's the value that we're bringing to the increasingly sort of AI hybrid that is our product and our company. And so I'll close, as I think someone who's spent a lot of time doing philosophy is likely to do, with a question. And so the questions that we used to ask a lot is, how will we make our AI agents transparent? How will we make them accountable? How will we make them explainable? How will we put humans in the loop? But I think the question better put, and the one that we're asking ourselves as we increasingly are pressured to bring AI tools into our company, and also build AI tools, is how do we design our relationship with the automation and the AI and the cognitive tasks that can perform with us, so that we can still explain ourselves, and taking that as a substantive lens on what we're doing, not just where do we save money, what roles can be replaced by the current technology, what sort of ideas about accuracy and efficiency do we want to pursue. We really want to optimize for this. And I'm sort of connecting that with the normative questions we had about the feature and the bigger institutional questions that we have about AI adoption. Thank you.
Okay, are there any questions for Andrew? Time for maybe a quick one or two. Okay, in the name of moving things along, actually, I think because of our time, we'll thank Andrew again and move on to our next speaker. Okay, our next speaker is Andras Rojas from the Vector Institute. And Andras' talk is going to be Collaboration in AI as a Pathway to Trustworthy Adoption. Looks good. Please take it away.
Yes. And hi, everyone. Thanks for being here. Yeah, it's interesting because the conversation so far has been going from something that is more about techniques and how you take those techniques and make it basically purpose fit. Then we move into organizations and how you try to ensure that that works. Again, how do you build that trustworthiness again on the models? I'm going to take it one step higher now to the ecosystem level, right? So to give a little bit of context for this presentation, in case you're not familiar with us, Vector Institute is a research institute. We are part of the Pan-Canadian AI strategy. And as such, our mission is to try to foster a healthy AI Canadian ecosystem. So as part of that process or as part of that journey, what we've been doing is working with many different stakeholders, some of those in industry, some of those in health, some of those in government, in different domains, basically, exploring different mechanisms to try to ensure that AI helps and basically makes people's lives better, right? So what I'm going to be talking about is roughly that. So if you want to take the highlight, basically just the key takeaway, what we've been building is collaborative strategies that can boost AI adoption at the ecosystem level. And we believe that Canada has the right infrastructure to lead on this shift. So essentially, the question now is, how can we build momentum, basically, to take the opportunity to shift a little bit of the direction in which AI has been going more recently, in terms of becoming a little bit more closed, and go back to the roots of being quite open and academic in nature, and then that shared pool of research, take it to the next level where it actually translates into products. So essentially, I'm going to be talking about three things today. So the first one is how the traditional closed mechanisms present challenges for AI specifically. And I'm pretty sure that most people here are going to kind of agree. So this is just mostly to level set and ensure that you have arguments when you are preaching to others. The other one is how collaborative mechanisms present opportunities. So we have evidence of how that directionally aligns. And finally, we already have mechanisms in place that can be leveraged to basically take us down that journey. So talking about the first part, why I say traditional closed models are not a good fit for AI, we have three main categories. So one is there are challenges with the IP protection of AI in terms of the traditional IP. So if you think of software development, there is one type of structure. AI is not a good fit for that necessarily at the beginning of the process. Then the speed and magnitude of change is so large. That is also another topic that I'm going to discuss. And finally, the increased opacity that is inherent to AI and basically machine learning overall. So talking about the first point, when we talk about the IP issue, if you think about algorithms, right, the algorithm itself is not IP protected. So there is a line where software is IP protected, but algorithms are not. The problem is AI doesn't really become an algorithm, an AI algorithm doesn't really become software until you train the model and you have the specific weights for your model. So as a result of that, you have a very big gap between what is published in literature, essentially, and the ability to use that in a practical way. And that is where there is room for building products. But at the same time, there is an opportunity in that gap to say, okay, so maybe we can put more resources to the first part, the part that is not IP protected, and build that more collaborative, right? While the subsequent parts of the model, when you are actually turning it into a product or into software, that is the part where you can definitely continue to build products and basically follow approaches more similar to what we do in software, in the software industry in general. The other big component, as I mentioned, is no institution can monitor this field alone. Last year, if you just look at the top 10 conferences, last year there were in the range of 24,000 papers accepted. That is, and of course it was a almost 30% increase year over year from 2024. So that doesn't include archive, that doesn't include all the journals, it doesn't include anything. I'm just talking about the top 10 conferences. So in total, if you include all of those, the number goes around 100,000 papers. So there is a practical challenge if you try to do it alone, which is trying to stay at the state of the art. It's really challenging if you're not part of a community. So these are some of the elements where, again, you have some companies, and that's why scale is so important for the hyperscalers, because that is the only way in which you can handle that volume of information in a meaningful way. But for most organizations, that is completely out of scope. So there are other options, right? That is not about making it more closed. And basically, it is one of the things where we believe that Canada has a leg up. Finally, the AI has a trust problem, right? And we all know about that. We were just watching some of the presentations that there is a lot of concerns about AI. And of course, there are things that I don't need to explain in detail, like, yeah, they are hard to explain, they can encode biases, they behave differently when you scale them, they drift. So there are all of these challenges, basically. If you add those to a legacy of transgressions, basically people that have blind spots and have ignored certain things, that has created a lot of mistrust overall. And of course, the other piece is, well, AI is new from the perspective of what we're seeing today. And as such, all the legacy governance infrastructure that we have, all the guardrails that we've built as society, they were not designed for AI. So there is a lot of gaps, and there is a lot of lack of maturity in the existing assurance models, regulation, and so on, right? So again, I think the bottom line here is trust us is not a governance strategy. So overall, being closed so far is not a sustainable model, or it is not a good fit naturally for AI, right? Then on the other side of the camp, when you talk about how good openness and collaboration serves this, basically, again, there are three areas that I want to discuss. One is the nature of AI as a general purpose technology. Of course, all the history of building AI on open collaboration. And finally, being more efficient about how we use our resources. So this is an example that I also always like to bring up. In one of our projects a while ago, we were talking about geospatial forecasting. And we had our engineering team put together a reference implementation that had kind of the vanilla flavor, if you want, of one of these geospatial forecasting techniques. And essentially, the core of geospatial forecasting is that the forecast on one node of this network is impacted by the forecast of the neighbors, right? So whenever you are thinking about a complex system, there is a lot of interactions that seems to be a good fit for geospatial forecasting. And in particular, one of the teams was doing a wildfire propagation use case, and another team was doing how much cash should you keep on ATMs. So same core code, taken in two very completely different directions by two companies. But this points back to what I'm mentioning before, that there is a layer where there is synergies that can be explored and actively exploited to be more effective, because AI is a general purpose technology, right? So building those core capabilities is quite powerful. This is another thing, and this, by the way, was prepared by Claude. So there may be some inaccuracies, but the point here was not really about being accurate. The point here was about the prompt, or what I was asking was, give me the top 10 technologies or techniques that have been developed on the open source space, and then give me the top 10 that have been developed in the closed or proprietary space, right? So the interesting thing, if you look at the list, again, my focus here is not accuracy, it's just to get a sense of what are the families of techniques that evolve in each of those. Of course, the ones that you see on the left side, they are foundational pieces. They are pieces that then we've continued to build on top of. And then when you look at things on the right side, they are products, essentially. Right? And that is, well, it's kind of natural that it happens that way. But the point here is, most of the things on the right side wouldn't exist if the things on the left side didn't exist, right? So part of what I want to mention here is that we have been building it in the open, and that is what has been driving the current revolution. So we shouldn't ignore that route. The other thing is that we have multiple layers, as I've been mentioning. So the core layer, when we talk about the algorithm, right, that is the actual techniques. And then you have a layer that can be co-developed, where you are building, for example, the model validation frameworks, explainability toolkits, governance templates. All of these things actually benefit from being collectively developed because it builds trust, it builds alignment. And then there is a third layer, which is the competitive edge, which is where you will certainly still need products. I'm not saying forget about products. The point is we still have these other lower layers where collaboration is particularly important. So that is essentially the message in terms of where the opportunities are. And part of what we've been doing, for example, at Vector, is exploring that in detail in terms of how we can actually build that infrastructure from a process perspective. So one of the key elements to consider is that openness is not a binary thing. There is certainly degrees. So some of the things that are quite open. If you go into the completely academic, we're talking about open publication, and then you can go into open benchmarks, open code, open data sets, open weights as a foundational piece, and then finally you have the things that would be more of at the product level, where you're fine-tuning the specific weights. But within this spectrum, there is a lot of room for exploring and finding and tuning, depending on your own use case, where you want to be. Right? And again, this connects back to that efficiency that I was mentioning. There is no point in actually trying to build the foundational layers in a completely closed models, because then everyone is replicating the same thing, right? Or something that is equivalent, functionally equivalent. So the results that we've seen, we have received feedback from our partners that the development cycle, whenever they've been able to participate in these projects, has gone down from around 6 months to about 6 weeks, right? So it's a material shift in terms of how much effort it takes to build things, because again, we are building together something that is foundational, and then on top of that is where they build their own product, their own protected thing, right? And we've tried these with more than 200 organizations. We've done around 600 use cases. These companies have invested over 250,000 hours to co-develop things with us, right? So, and they keep doing it. So all that I'm trying to say with all of this conversation is that it is a proven model. It's not something theoretical, right? The point overall is there is a model that can be achieved, that we think that can be generalized and scaled, where we can build or co-develop, right, AI in a way that is a lot more trustworthy through this type of a structure. So essentially what we're proposing is this confluence of 3 stakeholders. So on one side, we have the public sector, for example. On another side, we have private companies. And of course, it could be just private companies too. But I think it's particularly powerful when you merge different sectors that are partnering to actually build something together. Then you have a trusted third party. So of course, Vector is one of those, but we have all these national AI institutes. We have many other institutions can actually play this role. And Canada is particularly good at creating these type of institutions. So that can provide this additional layer of ensuring that best practices, well, and general assurance is achieved through these partnerships. So you have public sector, you have private companies working together. So public sector is signaling what are the priorities, what are the areas that we need to build on. Private companies are bringing in ideas and resources. And then these other third parties act as a validation mechanism that are saying, hey, this is how this is working. We provide scale and we provide coherence. So as the development goes forward, there is an additional layer of transparency of what's going on without putting at risk the IP side. And then finally, the ecosystem as a whole has a way to participate in this process, bringing additional legitimacy to the process. So overall, basically, Canada has these core strengths to champion these type of approaches, right? So the National AI Institutes in particular, we are all neutral third parties that are eager to support healthy ecosystems. And in addition to that, there is a huge boost, of course, in trying to create economic development through making government a first customer, for example, for AI innovation, and providing that human element, basically in terms of saying these are the things that are priorities for people, and this is what we need to build towards, right? So building that foundational layer, I think it's a big opportunity for Canada. So just to finish or to close here, so I do believe strongly that collaborative mechanisms can accelerate AI adoption, and I think it is something that where we have the opportunity to do that now. And again, enhanced transparency contributes to trustworthiness. The trusted neutral third party are here to boost credibility and technical maturity. So that is basically the element that we bring in, that overall trust in the reliability of the process, and we can turn AI as an engine for economic development. So I think there is an opportunity for us here to continue to push that. In particular, Atlantic Canada is particularly well positioned to also make a significant impact on this journey. So that's what I wanted to share. Thank you very much, everyone.
Thanks, Andreas. Do we have a quick question? Right here, Michael.
Thank you. Thank you very much for your talk. I think we all know in Canada, I think one particular strength we have is the government, right? And I very much like your idea having government being the first user of AI technology. So I have some examples in healthcare, but besides healthcare, can you name another maybe a couple of applications in government and how they advance AI technology?
So that is one of the big problems, that we have not been leveraging this as much as we should. So we've seen in healthcare in particular more adoption, right? We're hearing yesterday from some use cases. Some of the development or deployments have not worked particularly, I mean, they have worked well from a technical perspective, but not necessarily checking all the boxes on the trustworthiness element, right? So in Ontario, a couple of weeks ago, we had a finding from the general auditor that one of the scribe models, for example, was hallucinating and maybe was not properly checked before it was fully deployed. It doesn't mean that it's not working. It just means that there are some gaps in implementation. So one of the things that I could say, if I had kind of a magic wand and I could do whatever I want, I would not start with health, to be honest. I would start with use cases that are a lot less risky, but at the same time, because they are less risky, there seems to be a lot of reluctance to actually introduce change. So that is the part where we do have a moment in time now where there is a priority to accelerate, well, economic development. So I think now we are at a circumstance, basically, because of geopolitics and all of these things, that could actually help us break that status quo, basically, and create the momentum for start facilitating adoption in the public sector. There is a lot of things that we've done, for example, in the financial industry with banks that are an exact copy-paste to what could be done in government. So things around checking documents compliance, right? Or how do you complete paperwork? So things like that could be done fairly easily, to be honest, in many smaller scales within government. Not necessarily at the federal level to begin with, or maybe in some niche use cases. But I think it's mostly an opportunity rather than something that we have seen already working. Thank you.
It's great. Can we thank our speaker again? And we're going to keep it moving along here in the name of time. Okay, our next speaker is Amir Tavasoli from Sobeys/Empire. His talk today is going to be From Models to Decisions. Agentic AI for marketing mix optimization.
Does it look good? Good, perfect. Okay, sure. Hello, everyone. My name is Amir. I'm Director of Data Science in Marketing at Sobeys.
So today I'm going to show you one example of what it takes to get an AI model and put it in practice in a large-scale organization. What it takes, what are some considerations that you need to take, what are some of the challenges you run into. So that will be the focus of the talk. So from models to decision-making in a very large enterprise. So first I'm going to do a small intro to the McIntyre and what are the challenges that we face there in order to solve, and then a little bit of intro to marketing mixture modeling, because not everybody here is a marketing expert. And then I'm going to get into now how we brought agentic AI and marketing mixture modeling together at McIntyre to make decisions for our marketing and for our investment for the coming years, essentially. So a little bit about McIntyre. So, I mean, it requires no introduction. Like, I think most of you has shopped from one of these banners in the past year or so. But the main challenging fact about building models for an enterprise like this is, first of all, you have many banners. So, and they're very different from one another. Like, you know, Sobeys is very different from Farm Boy, from Foodland, from Freshco, from e-commerce platforms. So whatever you build has to work for everything, which is quite challenging. And not only that, they have their own teams too sometimes. They have their own marketing teams. They have their own ways of working that you need to respect. So it's more than just building one model that works for everything. Like, there is so much business layer you need to put on top of it to make it work. The other big challenge we have is that even everything we do is multi-channel. Like, our e-commerce is multi-channel. You can buy stuff from Voila, which is the preferred kind of e-commerce channel we have, but you can still buy it from Uber Eats, you can still buy it from DoorDash, and that's a required different approach to marketing. And also, like, we have private label as well. So, I mean, the way you calculate margin, the way you market stuff in private label and national labels are very different from one another too. So there's a lot of challenges you need to consider. Just want to give you the context that it takes a while to build something in a large organization, put it in practice. And now, what is the marketing mixture modeling? So it's an age-old question in marketing. So when we do marketing, does it make any sales impact or not? Like, this is like the first question. I ran a TV ad. Did it make any money? I ran like a big ad in magazine. Did it translate it into any sales? And in order to solve that, marketers use what they call a marketing mixture modeling, which is essentially a form of regression. It's not that complicated. So you put like sales as your target, and you put everything that you do as marketing as like a parameter, and also everything that you do as non-marketing, like how the market changes, what's the macroeconomic factors, how basically competition is doing. You put all of them in a massive regression, and once you get a good regression with a good accuracy, now you can go in and you can start like seeing which one is significant, which one actually had an impact. And not only you can do that, you can like nullify one and see what's the sales contribution of that one compared to when you don't nullify it. And then you can just take that sales contribution divided by the investment you did and come up with this return on ad spend, which is ROAS, which is what marketing like works with. So like you come up with this ROAS concept, and this ROAS can help you which marketing channels you want to invest in or which marketing channels you don't want to invest in. Because like if higher ROAS better, low ROAS channels, you don't like them. You not only can do that, you can take these essentially regressions and simulate it for different spends and create what we call like a response curve, and see, for example, like which channels are you towards saturation. So if you spend more, it doesn't matter. Which channels you're at the earliest stages that if you invest more, you're going to get a lot of gains from. And then you can put an optimization model on top, for example, mixed linear integer programming, and then you can just see if I have some inefficient channels like out of home or print, I can move the dollars toward more social because like it's more efficient, and then you can balance your marketing like spends like this. So as you can imagine, this is a pretty big process to do in marketing. First of all, to get the data, you need to go to multiple agencies, because you have your own marketing teams. Marketing teams work with agencies, and different banners work with different agencies, by the way. So go to them, get all the data you need at the granularity you need, at the format you need, at the accuracy you need, and then you need to do a lot to kind of even internally align on them and like to before building the model. And then you need to go to the data science team to build that process that I mentioned, build the regression model, build the response curve, build the optimization model. So this process can take sometimes 8 weeks, sometimes 20 weeks, depending how complex things are. So it's very slow. So every iteration of it's like optimizing the spend for marketing can take like a quarter, which is very inefficient, super inefficient. So the vision we had is that can we use AI and this marketing mixture modeling, put them together to be very efficient at that. So we can make decisions like in a few weeks or in a month, hopefully, or in a week even in future, so that we can go in and put like the AI agent does all the work at the back end for the marketers and they can make a decision. That's the idea that we wanted to go for. When we looked at the market, only like we have very mature marketing mixture modeling open source in the market. Like Facebook has Robin, like Google has Meridian, there's PyMC as well, if you like Bayesian. And there is like some commercial ones, like Nielsen has a model, but only 13% of them have any AI or agentic AI on top right now or to collaborate with. And most of those that we looked at, they were mostly in beta, and they were mostly done for data scientists, except maybe those Mutinex that we looked into, but still like it was at earlier stages. So we wanted to do this at Empire, so we decided to build this ourselves. So how we can build a solution like this ourselves, because the value that brings to us is so huge that it totally worth this investment. So we had the principles to design it. So we said, what are our design principles? So the first principle was that we went through many of these agentic frameworks and we realized like having a supervisor routing agent works very well in marketing. We saw like 7-Eleven talked about it, other places talked about it. We said having a supervisor agent and talking to other agents, that's the main route to go. And then the other thing, we want to use the tools and the algorithms that is already developed. We don't want to redevelop something from scratch. If we have something, we want to use it as a tool here. And we want to use this agent as a single source of truth for our data. That's another very important thing, because what is truth is very relative in marketing. Like, you know, say they have a view for their agency, they have a view for their brand, how you can create a single source of truth that everybody agrees on. And then another principle we were following was to have like keep the memory of the agent and have a long-term memory, short-term memory, and a shared memory between the planners. So like if a planner is very good at doing something, it helps the agent to help the other planners as well to do a better job too. So having a shared kind of memory between them was very important for us too. And we wanted to, as much as possible, make this a business front end. And we didn't want to build a data science agent. We wanted to build an agent for marketers. And then the math and everything done at the back end, so they don't need to worry about it too much. At the same time, you want it to be explainable and you want it to be repeatable. Because one thing is that the LLMs are not really good at like when it comes to like optimization, like doing the same thing over and over again. Depending on the version of the model you use or the prompt you use, this changes a little bit. So we decided that we're going to still use our classic algorithms that is trustworthy. We know it works. We can just put the LLM as an interpreter. And then those algorithms are very interpretable, like regression or mixed linear optimization. It's completely interpretable. So why we should put an LLM there that is not really good at? And when we look at the papers, most papers, like they said, they are not really good at doing investments right now, even the frontier models that we have today. So the architecture that we came up with was something like this, like at high level. We have a supervisor agent that you can ask it any question. So it acts as a guardrail. It acts as a guardrail. Also, it acts as like a kind of moving the question to the right agent. If you have a generic data question, it goes to your data agent, which is a text-to-SQL agent, which we're using Databricks for it. We're using the Genie right now. And you can ask it any question. It can build charts for you. It can like create reports for you. So it's pretty extensive. So it covers the analytical needs of the marketing team, which by itself is a huge win. And then we have an agent that does essentially prediction. What if I increase the investment next year in December? What would happen to this channel? What would happen to that channel? And it can use those response curves to do prediction. And we built an optimization agent that if you say, okay, I have $2 million, give me the best investment, which is the kind of gold question here, and marketers want to use that. And that agent, we build an agent that works with that optimizer as well, and they can kind of put the investment in the right place. And of course, everything we keep track of, we have a memory of everything, and we have a feedback loop of these memories to make them better as the time goes. So this is essentially combining all these basically analytics that we were talking about for years, descriptive, predictive, and prescriptive analytics. So you have a tool that can do it all. It's like up to you which one do you ask. Because previously, each of them had their own tools. We had a descriptive model, we had a prescriptive model, we had a predictive. You have to log into a different thing, we'd give you a now you just ask, just ask that agent in front of you and it just gives you the answer right away. So our approach, compared to what has been done before, is that most of the other agents that we saw out there is built for data scientists, whereas our agent, as I said, is built for marketers, and it's the masses, everything's taken care of at the back end. And then most of those basically approaches, they are not designed to cover enterprise level marketing mixture model. It's just like a support tool for a data scientist to put the data in there, play around, build a model, and give a report. Whereas what we have is automates the whole process end to end. The data, the agentic part, the reporting part, everything done in an automated way end to end. And that's the difference between looking at things from theory standpoint versus an enterprise standpoint, that you need to do stuff maybe a little bit differently on the same team to get the results that you need at the enterprise level. So basically, what we learned from this was that you should use models to inform most of the time. The ML models you have is really good. So you can use them for inform. Agents can make decisions and help you make decisions. And most of the time, we have so many ML models in enterprises. The issue is putting these models in front of business rather than we need a new type of intelligence. Most of the time, the access is the issue, which the agentic AI can democratize and help them work with these agents. And we found this to be a very good blueprint, and we're using it at Empire. We're already seeing massive cost savings across our marketing team using this tool, because they are going in asking it questions that we didn't even think about, and they're finding opportunities to do cost savings, to do things more efficiently, and we're already seeing this running at scale. And it's at the earliest stages of its adoption, but we're already seeing good results from it. And thank you very much for listening in.
Okay, thanks, Amir. We have time for one question for Amir, if anyone has anything. Oh. One question back here.
Thank you so much for your talk. And I had a question. What would you say is the easiest, most efficient way to create a similar AI agentic flow within my company, for example?
So, I mean, if you have a marketing mix model already set up at your end, and you have optimization model already set up at your end, if you have all of them set up, you just need to, we used basically LangChain, and we use Databricks to do it. So if you have any platform that supports LangChain, we can just do it. And most of this would be a lot of prompt engineering of how you want the agent to interact with the current models you have. How you design those tools is the key. So you just design the tools properly, put it in this agentic framework. At the prototype level, shouldn't take a long time. But going to enterprise, depending, as I mentioned, in the nuances of how you would do this in your organization versus, for example, what we did in the Empire.
All right, thanks again, Amir. That was fantastic. We've got one more speaker for this session. This is Dr. Danny Silver from Acadia University, and his talk is going to be Managing Applied AI Data Science Research Projects with Industry Partners.
Morning, everyone. You can't hear me. Because very good. Thanks. So how many of you have been involved in a academic industry applied research project? Don't be shy. This is, it's almost lunchtime, and I know I'm between you and it. So, how many academics do we have here that have been involved in such projects? And on the industry side, how many folks have been involved? A little fewer on the industry side. And how many students are here? Few? Good, great. So what I want to talk to you about is just some of the big do's and do nots in this space. And I don't know how I got that far on my slides already, but and that's managing these types of applied projects, particularly with industry. So they can be really quite rewarding, but there's a big difference between these applied projects and working in more fundamental research, which I've done both over a number of years, too many years. They can be rewarding in that it can be involve a lot of continuing work with the same company or companies in that space. It can be done with a lot of graduate students. They can take on jobs. It's sometimes easier to get some really good funding for these projects, and you're contributing to real-world problems, or solutions to those real-world problems. But it's challenging in that you're working with industry partners and everything that comes with that. So I'm going to provide this more from an academic perspective, but there's a lot to be, I think, acknowledged here from the industry side as well. So success, of course, requires then great leadership, good project management, great communication skills, working diligently on everything, and managing the challenges early on before they become really serious. So one of the first things that I've tended to do, particularly through the Institute for Data Analytics at Acadia, working with Andy as a matter of fact, has been to ensure that the industry partner that we're working with is committed and quite capable of taking on their portion of the project. So this means getting them to write down what their company is about and what they would like to achieve, essentially working towards a definition of the problem. And understanding the people that you're going to be working with and their backgrounds. Are they capable of doing the things that are going to be necessary in the projects? And you can get assistance from your industry and community engagement office or industry engagement offices, and also with contacts with people in ACOA, NSERC, NRC, groups like this. And at the end of the day, once you've sat down with them, done your homework in these areas, if it doesn't feel good to you for lots of reasons, then it's probably better not to do it. So working with your, how many people have worked here with your industry liaison offices before? Just a couple? No? Well, they're great folks to go to in your university. They can help you with making those connections for funding, certainly in the legal and contract sorts of areas, and for issues around project management. One of the other challenging things to do, and that's often misunderstood on the part of the commercial partners, is that this trade-off that's happening. From the commercial partner perspective, they're seeing the fact that working with the university, the cost is going to be much lower than if they were working with a professional services provider. The question about that. But there is a trade-off in that, and that is that universities do good research, right? They generate theories and approaches, and they develop and test prototypes and things like this. What they don't do is they don't produce production-ready systems, and they don't do ongoing maintenance. If people tell you that they do that, they're incorrect. It just doesn't work very well. So don't expect those types of things to be done. The company's next step after successful, hopefully, prototype, testing a concept, that is the next step towards building, developing, and maintaining a production-oriented system. So companies out of this get solution ideas, potentially really good solutions that recoded in a more production-oriented environment are ready to go, and the intellectual property should be there. So I'm a firm believer in that. The principal investigator at the university, on the other hand, gets student funding largely. In most cases, the professors get very little financially from this. It's really the reward of working on the projects and doing something real, and potentially, depending how the project what area it's in, et cetera, there may be the right to publish. Most professors would like that, and potentially even royalties, but not necessarily. So now to talk a little bit about what you can control and what you can't control. So establishing realistic objectives is probably one of the biggest things, and leading to a definition of the problems where we're really headed here. So defining all the deliverables that you'll be providing to the industry partner early on is the data, the software, the models, the hardware potentially, and documentation is really important. And then control the selecting the RAs, the students, or perhaps someone's recently graduated, they're hiring to work on the project, make sure they have the ability to complete that. Preferably, you have a student in mind before you sign all the contracts. That's not always possible, but it really does breed success if you do that. So lots of good planning, and building in contingencies, of course, is always a good idea, both in terms of the plan, the budget, the funding models, and the contingencies in that respect, if something should fall through, and that checking that the partner has the necessary capabilities, the resources on their end. One of the things that most of you, if you've been involved in the academic side or just in the consulting side, you work with a company and there's that tendency towards, okay, now you've got the problem, run away, solve the problem, come back when it's all done. And of course, that's rarely the case, rarely how it works. There's an ongoing relationship and working on these things. Problem definition is the key to success in these areas. I mean, this goes back to, software engineering 101, requirements analysis, problem definition. That's certainly true in AI, data science types of problems. The first one is to really carefully define the business problem. What is it that the business wants to accomplish? Right a look? And, translating that into a technical data science, AI type of problem. And with, really clear success criteria. What's that, how are you going to measure it when you're done? Is it in fact something that, surprising is not that much? So it's just examples here is, a very simple one. We want a better website that increases our cross sales by recommending, related products to our customers that they're looking. That's the business sort of objective. That translates into using some type of machine learning technology, XYZ. You may want to stipulate that because the company ultimately is going to have to use something to actually employ it in the production system. So the closer it is to the real thing for them, the better. That it's going to use a machine learning recommendation system, in this case, to cross-sell and make those recommendations through the web services they have available, and that it's going to increase gross sales by 10%. So you have a measurement metric in place for all that. So what you can't control, one of the challenging things here oftentimes is the industry partner to be aware of the fact that students, if they're their RAs, are not employees. Students will decide to leave the program. They will switch professors and projects within the university. They may want to switch to a different degree program. All these things kind of happen. So companies need to know this, right? It's another reason why don't be thinking production systems, et cetera, like that. So this is likely, there's no likely immediate replacement for an RA if they happen to do this. It could take a bit of time. So there's going to have to be some flexibility on the part of everyone to make this work. So it's important, I think a lot of this is adding up to, particularly if you're a startup, is that the results of this project may not be as near term as you might think, that it's going to take perhaps a little longer if a few bad things happen along the way. And also you have to clarify to the RAs what their challenges are, what they're going to be faced with, what their responsibilities are. They need to know that they'd be able to understand what the project proposal, the plan is. They should have all this information before them to sign on. They need to know where and when they're going to be working. Do they need a car and a license? That one's got me at least twice, finding out that in one case the person had a car but didn't have their license. It's a strange one. It's true. They need to sign off on the requirement documents too. And sometimes this is an area where your liaison office may not have some of these things for students. And the principal investigator, the RAs, need to know their respective responsibilities, particularly if it involves a student that's your institution, because there may be some written guidelines in that area as well as things going on in the project in particular. And then, of course, there's all of the usual project management things that go through the typical 4 sets of planning, organizing, monitoring, and leadership. Well, most of you know quite a bit about that, hopefully. One of the ones, though, that I just want to talk about is scope. One of the great things to define early on in that process of defining the problem, laying down the objectives, is determining what's within the project and what's outside of the project. It really helps to demarcate what you're doing and communicate well between yourself and the industry partners, setting expectations as what's going to be achieved by the project. I'm going to jump over that. Organization and communications. It's great to have a project kickoff, of course, in person. A lot of these projects can happen with the supervisor, the PI, and the students in the university setting, working with the industry partner over distance. But it's great to have in person, touching hands, meeting individuals, doing that a couple times if you can, and in that process, in that initial setting, identifying if there's problems or misunderstandings. I've had situations, I remember one particular case in the Maritimes where after we won a significant project, myself and the other individual from DAL went to the companies and the principal announced, well, now you're one of our employees, sort of thing. And that probably wasn't the best start. Not understanding that, no, we're not one of your employees. That's not how this works. So you got to clear those things up early on. If major problems are identified, this process, they need to be corrected. And then having weekly meetings with your RAs, of course, it's just team meetings, and having ongoing meetings with sometimes over the web with your business partners, monthly, good documentation and minutes from those things, the usual change management stuff that might happen. And then, of course, monitoring and controlling the project continues to be really important. In particular, the PI has to be continually assessing risks. Talking with people is the key. Good communications, making sure that people have a share in both setting and establishing what things are going wrong, as well as helping to solve those problems. And lastly, of course, leadership is always the key. You're going to encounter challenges, right? You're going to make your share of mistakes. You're going to contribute to things, but your ability to say, that was on me. I'm sorry. I'm going to do better. And moving on is the key to make both getting better at those things and also keeping the team working well. So thank you very much. I could talk about this for an hour, but if there's any questions here or afterward at lunch, be happy to discuss them with you.
Okay, this is our last talk for this session. Was there any questions for Danny? If not, I have one. Maybe, Danny, what would be the reason that industry projects, the collaborations most typically fail?
Yeah, well, definitely the things I pointed out in the beginning here, the defining of the problem and the setting the expectations between the two partners, right? That it's very common in computer science. They say that about 70% of computer science projects in general, most certainly AI, fail. And it's mostly because it's that thing where the computer science turns up the shiny, colorful screens doing things, and the person goes, well, that's really cool, but that's not what we really wanted. So number one is defining the problem and then setting expectations for what is going to be achieved. That no, this is not going to be a turnkey system that's ready to go with your customers when we're done. Again, if people in university are telling you that that's what they're going to do, then I wish them great luck. It's probably the first time they're doing it if they're telling you that. So don't get caught in that trap.
Excellent. Any other questions for Danny? Okay, thank Danny again, the speaker, and this is the end of this session. I think we're due for lunch by the sounds of things down here.